Hello class, today we are on day 4 of our oceans book. Again, you can find that oceans book on our bookshelf in our classroom. It's right in the middle of the bookshelf on that second shelf. We are going to be reading all the way through to the end of the book today. We're going to be learning more about waves. In our last lesson on this, on our day 3 oceans, we were learning about tides and how those work, and we learned about a special kind of tidal wave called the tsunami. Today we're going to learn a little bit more about waves, especially 4 very important terms. The terms are trough, crest, fetch, and breakers, and 3 of those are in your vocabulary for today. So the crest is a noun or a verb that means the top of something, especially if it's pointed. So you might have seen that some birds have crests of feathers. They're kind of like pointed up, or sometimes you might see a crest of feathers on a bird's head. Mountains also have crests, so that's like where they come up to a point. And we're going to see today that waves also have crests, so there's waves that will come up to a point. We're also going to be learning about trough. A trough is a noun that means a long, narrow, open container to give animals food or water. It also means the low space between 2 wave crests. So it's going to be kind of like a valley or between those 2 waves. And then we have fetch, which is a verb, so it's an action word. That means to bring back. But it's also a noun, so it's also a thing when we're talking about oceans. That means the distance traveled by wind or water. And we'll talk a little bit more about that as we get into our book. So let's go ahead and start on this first page. Again, read aloud with me just to help us become better readers. And we'll start here. When the wind blows across the surface of ocean waters, little ripples form. As the wind continues to blow, the ripples grow into waves. The size of a wave depends upon the speed of the wind, how long it blows, and the fetch. So the fetch is the distance over which the wave travels. The faster the wind, the longer it blows, and the greater the fetch, the bigger the waves. In the open ocean, where the wind is blowing and making waves, the waves are all different sizes and shapes and go in different directions. As the waves move away from where they began, some travel faster than others, and they form groups of about the same wavelength. The waves are now long and smooth and are called a swell. And so we have a picture kind of that. So if we're looking at that picture, see where the waves kind of come up to a peak right here? So every time you see one of those peaks, that's what we're calling a crest. And then if you look like at a pair of waves, so let's say we bought this one here and this one here, that space where it kind of makes that dip or that valley, that's called the trough. Then that distance there of the wave is called its fetch. And here's some diagrams for here that helps us to point that out. So again, crest, trough here at the bottom, and then a wave length is from crest to crest, and then it's showing you that whole length there. It's called its fetch. And this here is talking about the wind. So those arrows are where the wind's striking, so the water is pushed into the waves. I believe that gets extended on the next page as well. So starting here, waves moving across the ocean carry the energy of the wind, but the ocean water does not move along with the wave. As the wave passes, the particles of water move up and down and around in a little circle. If you watch a stick floating on water as waves pass by, you'll see that it bobs up and down, but stays in just about the same place. Only the energy of the waves moves forward. So if you were to try that at home, maybe even shake a cup or get a cup of water and swirl it and try to put something in the center, you'll notice that whatever you put in it stays in about the same spot. It's just the energy of the water that moves. A little bit more of your pictures here. So again, we've got some directional arrows. We can see the spinning that they're talking about. And then the cross brush forward is breaker. So when it hits the sand here, that's when it becomes a breaker. And I'm sure you've seen those before, even at lakes. All right, this paragraph here. The high spot of a wave is called a crest, and the low spot is called a trough. The distance between 2 crests, or between 2 troughs, is called the wavelength. The height of a wave is the distance from crest to trough. So if we were to look at that in that picture, so you would have, here's a crest to crest, that's a wavelength, or you can count it this way. There's trough to trough, so you could count that as a wavelength. And then that other part they were talking about, the height of the wave, would be how tall it is from here, so the bottom of a trough, to the top of the waves that are next to it. Here's a picture of a boat kind of riding out those waves. I don't know if I would like that, really. Storm-driven waves in the ocean can build up to great heights. One of the largest waves ever was 112 feet high, the height of a 10-story building. So a 10-story building, that would be huge. So I can't even imagine how enormous that wave was. Ocean-going ships can ride over most waves. Small ships can ride up one side of a wave and down the other. Large ships can usually ride through waves without too much difficulty. During a hurricane or severe storm, however, a huge wave can dump hundreds of tons of water onto a ship in a few seconds, smashing it apart and sending it to the bottom. There's another picture of waves, and it looks like if you look close, you can see somebody up there trying to ride the wave with his board. When an ocean wave reaches the shallow water of shore, it begins to travel more slowly and its shape begins to change. Some people say that the wave begins to feel the bottom. Waves begin to pile up and grow higher as those in the back come in faster than those in the front are moving. As the waves slow down, the crest of the wave tries to continue at the same speed until finally it topples over into the trough of the wave in front and becomes a breaker. When waves break on the shore, the surf begins. Sometimes surf can break just a few yards from shore. However, if the shore is shallow, surf can form hundreds of yards out to sea. The waves of shallow beaches, such as this one in Hawaii, spill over slowly as they roll up the shore. Wow, that looks like a pretty nice big wave there. Even rocky coastlines, so we're kind of changing subjects here, even rocky coastlines are worn away by the power of the surf. The softer kinds of rock are worn away first, leaving rocky spires or platforms of harder rock. These too will eventually be worn down by the pounding of the waves. In other places, the incoming surf carries sand particles from one spot to another, slowly building up beaches and dunes. Every moment of every day, the sea is at work, reshaping the land. I'm going to reread these first two sentences again because I know that there's a question in Bookworms that's going to have something to do with this. Even rocky coastlines are worn away by the power of the surf. The softer kinds of rock are worn away first, leaving rocky spires or platforms of harder rock. These too will eventually be worn down by the pounding of the waves. So we can see a picture here that looks like there's different areas of this geographical feature that are kind of cut in and maybe worn away. So I believe in your Bookworms, it's going to ask you something about the geographical features that you're seeing, in particular, this formation right here. So we can see a picture of these different rocks. How on earth did they get jagged like that? Well, we'd have to go back to that other page, look at that description again, and see if we can figure it out. How did these get shaped the way they are? All right, we're switching topics just a little bit here again. So millions upon millions of years ago, life began in the sea. Today, the sea is home to incredible numbers of living things, from microscopic plants and animals called plankton to giant whales larger than any dinosaur. Some animals are drifters, others swim freely, and still others spend their entire lives on the bottom of the sea. So we have a picture here of a couple of starfish. And there's a whole school of fish there. One way or another, all sea animals depend upon the multitudes of tiny plankton plants. Where have we heard that before? Which drift in the surface waters of the ocean, using the energy of sunlight to produce food. The tiny plants are eaten by small fish and other animals, which are eaten by large animals, and which are eaten in turn by even larger animals. Many tons of sea animals of all kinds are eaten each day by people all over the world. And there's another nice picture. Throughout the ages, the sea has been the inspiration for art, music, and poetry, as well as a source of food and a highway to travel. The sea has also been used as the world's wastebasket for garbage and even radioactive waste. Until now, the sea has always been able to renew itself, but we are reaching the limits of this vast ocean world, and without the sea, the earth would be a world without life. Then we have the end of our book here. And what I want to point out is it does have a glossary in the back. It's a very limited glossary, but it does have those some of those vocabulary words that we've looked at. And then it does have a small index here as well. So if there was something particular you wanted to look up, you would be able to find it and then see the page number that it was on. Here's a list of books if you wanted more books by the author. And here's a listing of them there. Or if you just want more information about oceans, it gives us a couple of websites that we might be able to go to. And that is the end of our book. So now you just need to do the work that was assigned for today, and you will be all set to turn that in.